okay?
Go.
Okay. You can't really simplify that one. So then this one becomes x and 3 and 6. And that. And then
X minus 6.
so then there's no holes because you didn't cancel out anything.
That's okay.
Okay, whatever, let's just, yeah. And then y-intercept. Well, let's do the VA first. In VA, you look at the bottom. And wait.
Yeah, you're right. You look at the bottom. So what would be the vertical asymptote?
There's 2 of them. So then x equals 6 and x equals -3.
Very good. Let's graph them with a different color. So this is when you know you have like 3 parts of a graph. Very good. Okay. So what would be your horizontal asymptote?
Horizontal, you look at both of them, and it's
Look, is it big on bottom, big on top, or the same?
bottom, so it's y equals 0.
Yeah. So remember, every time you want to decide whether it's a horizontal asymptote or not, you have to look at the powers. If the power is, if it's heavier on bottom, it means y equals 0. So boba, big on bottom, 0. So y equals 0 is your horizontal asymptote. Big on top, it means there's no horizontal asymptote. There could be a slanted asymptote, okay? And there's one more. Bosco, both same. If they have the same power, then you take the coefficients, okay?
Okay.
So y equals 0, can you graph that also? So remember, so can you have an x-intercept? Graph it.
No.
Because the y equals 0 is your asymptote, so you can, then the x-axis, so you cannot have an x-intercept. So you don't even think of it.
So no y-intercept.
No x-intercept.
I mean, yeah, that's what I meant. And then the y-intercept is, when you put 0 in, so 2 over actually that'll be easier. 0 minus 6.
So 2 over negative 18, because if x equals 0, it cancels out. If x equals 0, it will cancel out this one, will be gone, and this one will be gone because it's all 0. So 2 over negative 18. So it's always easier to look at the standard form. And 2 over negative 18 would be how much? Let me just erase this. And 2 over negative 18 would be how much?
9.
Like
no,
negative
negative
1 over 9.
1 over 9.
So it's like negative 0 point something.
So,
Okay. Now,
okay, that just made it worse.
okay, now, it's very important to look at, your asymptotes, because like you might think there is an x-intercept, but there's not. Okay, we'll talk about that.
Okay.
Okay, Because like, look, if you look at your function, and you will say that to find the y-intercept means you have to look on top, right? What's the top?
5x plus 2.
You would 5x plus 2, you said equal to 0, so you think that your x-intercept is negative 2 over 5. Okay? So it does make sense. But when you come and graph it, oh wait, we have an asymptote where? Where do we have an asymptote? At the y equals 0, at the x-axis. So could there be an x-intercept? No. Okay? So I know the x-intercept, you look at the top and you solve it, yes. But first of all, check. If the x-axis is an asymptote, you don't even have to go through that. Make sense what I'm trying to say? So if you try to solve it, it will give you a number, but that number is not acceptable. Make sense? Okay. So there's no hole. You did the x-intercept and the y-intercept. You did everything that you need to do.
I'm gonna graph.
So now we have to graph it. Okay. Now, so where is the y-intercept?
Right there.
There, okay. Is there anything that helps us know how to graph? Is there anything? Okay. There's
You have
nothing.
to plug in points.
So that's why you have to plug in points. Now, how can you choose those points?
To the left.
To the left. So pick a point to the left of this one.
-1.
To the left. Let's start with here. So what's
Oh,
this?
like over here? -4.
So -4. So plug in -4. Where would be easy to plug it here or in there?
Okay, so 5 times 4 is 20 plus 2, so it's 20. 22 over -4 squared is -16 minus 4 times 3 is 12, and then, or negative, it's positive 12, and then minus 18. So
Okay, so for -4, what did you get?
30.
-4 over 5. How did you? Okay, let's see.
I know, but I got
Let's see.
that, and then you have to.
So, if x is equal to -4, and you chose -4 because it's on this side, right? X equals -4. Okay? So x equals -4. It means that y would be 5 times -4 is
It's okay.
-4, right?
20. Wait, 5 times -4 is -20.
-20 plus 2,
18. -18.
-18 over. Now I'm going to plug -4 in here. -4 minus 6 would be?
-10.
Very good.
And then,
-4 plus 3 would be?
-1.
-1.
So, -18 over 10.
-18 or over 10. Divide by 2. So that would be 9 over 5. Now, let me see what I did over here.
So 1 4/5.
So, or it doesn't, like, you really care about it being like -5 over 4, so that would be 0 point or 1 point what? 1.8. -1.8. So, where would it be? So, -4. So, -4. 1, 2, -4 and -1.8, so somewhere over here, so then you know that your graph is over here. Like, she doesn't really care about other points. She just wants you to know that your graph then is going to be over here. Make sense? So, whenever you have 3 steps, 3 places, you have to
Is
just...
it negative? Okay, yeah.
So then it's on the bottom. Okay? Now, you have to pick... Now, you know that there's a point over here. But you don't know. Is your graph going to look something like this? Something like this? Just a quadratic? Just a quadratic? So there's like a lot of things that you can do. So what you need to do is pick a number to the left of it and a number to the right of it and see how it looks, okay? And again, pick a number over here. Now, most of the time it's going to be over here, but you want to be on the safe side. You don't want to just guess. So pick a number also on this side. Make sense what you need to do? Okay, so what would be a number that would make sense to pick up? Maybe -1. So go ahead, plug it in and check what happens if x equals -1.
So -1 times 5 is -5 plus 2 is -3.
Okay.
-3 over negative. What are we testing again?
-1.
-1.
So -1 minus 6 would be?
-7.
So, and -1 plus 3 would be?
2.
2, so -7 times 2 would be?
-14.
So it's like 0 point something, it's plus. You don't really care about the precise, but it's plus 0 point something, so where would it be? Or this one.
Yeah.
Okay.
0 point.
So -1 and 0 point. So it's going to be somewhere over here. Okay. Now pick a number to the left of it. What would that be?
1.
1. Okay, choose this one because when you make it closer, it will not
Yeah.
squiggle. Okay, so 1. Okay. Let's try 1. So 5 plus 2 would be?
Wait. Oh, 7.
Okay, so 7 on top. And then 1 minus 6 would be?
5.
-5. And then 1 plus 3 would be?
4.
So it's going to be 7 over -20, so it's going to be -0 point something, okay? So I just made it bigger. So 1 and where would it be?
Like here.
Somewhere over here. Now you know then your graph is going to look how? Wait. There you go. Try. Now see what you need to do. Here, sorry. Here, you need to just try to make it like come closer to the asymptote. Okay, so this wouldn't be it, okay?
Okay.
Make sense? Now the other point would be what? This is 6, so 7,
7.
maybe? 7, so plug in 7. 5 times 7 is?
35.
Plus 2.
37.
So 37 on top. Over 7 minus 6 would be?
1.
1 plus 3 would be?
Wait, 7 plus 3.
Oh, 7 plus 3 would be?
10.
10. So 37 over 10, like, so 3.7.
3.7.
So then it's 7 and then 3.7. Isn't 7 over here?
Wow.
Okay. So you know, so you just try to graph something that would come so close to the asymptotes. So there's it. Okay, makes sense?
Yeah.
So every time you have 3 asymptotes and you don't know, it's not only if you have 2 asymptotes, 2 vertical asymptotes. It's if you, so it's not if you have 3 asymptotes. It's even if you don't have a point and you don't know where your graph is going to be, top or bottom, you just pick a point, you plug it in. Okay? Questions? You got it? You feel better about graphing? End behavior. Do you know what is she teaching you? End behavior?
Yeah, I think so.
She is. I didn't see it on your notebook.
Well, like, not actually writing it, but yeah, I think my mom's outside. Wait, she said whenever you're done, I'll be waiting outside.
Okay. So do you understand it?
Yeah.
Here, like, let me just say it really quick. If you have something for end behavior.
Oh, did you touch it?
Yeah. Did I scratch it? Okay. So, because this is a pen. So, end behavior, it means like on the left, if you look at the left side, x tends to negative infinity, it means to the left side of your graph. To the left side of your graph, what is your graph coming close to what?
0.
0. So you look at the horizontal asymptote most of the time. So 0. And on the right side, x plus infinity means to the right side. So look at the right side. Also, your graph is coming so close to the x-axis, so which is the 0. So every time you want to find the end behavior, you will just look at the horizontal asymptote. Okay? Make sense? Okay, look through everything.